What is Hadoop? Why we are using Hadoop? So anyone knows why we are using Hadoop? So first of all, before going to Hadoop, first of all, I want to discuss about data, big data, and Hadoop. Now tell me, what is data? Basically, data is an information. Basically, data is an information. But nowadays we call it as data is a currency. But data is a currency. Why we call it as data is a currency? The first example. So Facebook. Mark Zuckerberg. Mark Zuckerberg is introduced this Facebook. Nowadays, no, so many people, millions of people are using Facebook. Not only Facebook, WhatsApp and Instagrams, these two are nowadays Facebook products only. If you open Instagram from Facebook, if you open WhatsApp from Facebook, am I right? So nowadays, so many millions of people are using these apps, and they can upload their daily chart and upload their photos, videos, likes, comments, shares. Uh, Suppose if you want to create any page in that vlogs, so many things, not only one thing, so many things. So they are maintaining huge volume of data. They are maintaining huge volume of data. So that's why Facebook, Mark Zuckerberg is a top fifth richest person in US. The first richest person is Amazon. The first richest person is Amazon. So these are all everyone, they are playing or they are maintaining data only, and they are processing the data only. They are store the data only. Based on the data only, they are getting so many amount, so much of amount. So that's why nowadays data is called it as a currency. Data is called it as currency. If you take the Indian apps nowadays, Swiggy, Swiggy app, so many people are using Swiggy app. Okay. Swiggy app. Nowadays, Indian people are using Swiggy app. Swiggy app also generating more data. How? You are daily you are order a food item by using Swiggy. So in the Swiggy also, so many transactions are done. So they are maintaining also so much data. Okay. So that's why nowadays data is currency. Data is currency. Okay. Now, what is big data? What is big data? A big data, it is nothing but a huge volume of data. That is nothing but big data. It is nothing but huge volume of data. It's called it as big data. Okay. Suppose for example, suppose for example, in 1970s, after 1970s, the data is very less. The data is very less. It is in the form of KB. Suppose, for example, all of them are BTech background people. Suppose everyone BTech fourth year CSE branch. Suppose A comma B comma C sections are available. So total 180 people are available. Each section contains 60 students. Total 180 students are available. Now, can you please tell me how to process this data and how to store the data? For every data, we can use processing plus storage. So how can we do this? How can we do this? By using Excel sheets. By using Excel sheets. Okay. After 1980s, after 1980s, the data is much more bigger. It is in the form of MB. What is MB? It's a megabytes. Suppose, for example, how to process this megabytes of data by using for processing we can use a programming language, that is called it as Java or .NET. Java or .NET. For processing, for storage, we can use RDBMS. What is RDBMS? Relational Database Management System. That is nothing but MySQL, SQL, Oracle Server, SQL Server, anything. Okay. After 1990s, the data is much more bigger. It is in the form of GB. So how to process the data? By using MSBI, comma, Oracle BI. Okay, and also we can process the data. How we can process the data? By using, Netezza, comma, Vertica, and Teradata for storage purpose. After that, the data is much more bigger. It is in the form of TBs. It is in the form of PBs. It is in the form of Jdbs, YBs, and EBs. That is nothing but terabytes, petabytes, zettabytes, yottabytes, and yettabytes. Okay. Now, this volume, we call it as huge volume of data. This is huge volume of data. Nowadays, Facebook, Amazon, so much of data they are generating. This volume of data we call it as big data. What is big data? Big data is a problem statement. For every problem statement, we have a solution. For this problem statement, our solution is Hadoop. What is Hadoop? Hadoop is a framework. We can we can process this big data by using Hadoop. We can store by use. Hello. Can you please mute? Can you please mute? Kumar, can you please mute? Okay, thank you. Now, so Hadoop is a framework. Or technology to process and store huge volume of data. That is nothing but big data. Now, so can you please anyone tell me why RDBMS cannot process huge volume of data, and why Hadoop will process huge volume of data? Any idea, guys? Can you please give answer in your chat box? Do you have any idea about why RDBMS cannot process huge volume of data? Why Hadoop is processing huge volume of data? Guys, any idea? Can you please respond? Am I audible, guys? Am I audible? Okay, cool. So any idea about why RDBMS cannot process huge volume of data? Okay, I will tell you. Okay. So basically we have two types of scalings are available. We have total two types of scalings are available. Have you guys know vertical scaling and horizontal scaling? Have you guys heard vertical and horizontal scaling? Any idea? Okay. I will give the example so that I don't know, sorry. Okay, first one is vertical scaling. What is the meaning of scaling? Scaling, it is nothing but add or remove components. Add or remove components. So in our vertical scaling, only we have one system, one CPU. Only one system, one CPU, RAM, I mean to say hard disk and processor. So we need to scaling. What is the scaling? It is nothing but we can add or remove components. For example, at the time of system, you can purchase. So the RAM configurations, the system configurations are RAM is 4 GB and your hard disk is 500 GB and your processor is a 5 gigahertz processor. But after some days your data is much more bigger, it is 2 terabytes. So what you need to do, you need to increase your RAM size up to 16 GB and you can hard disk you can upgrade from 500 GB to 2 terabytes, and also you can increase your processor also. But suppose if your data is 10 terabytes, but then you cannot increase because we have some limitations in vertical scaling. In vertical scaling we have some limitations. Up to some certain point only we can able to add. But now coming to horizontal scaling. In this horizontal scaling, suppose if you want to process 4 terabytes of data, first we can take 4 CPUs. One CPU, it is nothing but one system. One CPU, it is nothing but one system. Suppose four systems we can use for 4 terabytes of data. So here we call it as these boxes, we call it as not CPU. Just for your understanding purpose, I have given this CPU1, CPU2, CPU3, and CPU4. But usually this is not a CPUs. What is this? These are call it as we can call it as nodes. We can call it as nodes. I will tell you, Ravi. I will tell you nodes. Node 1, node 2, node 3, node 4. Suppose the data is much more bigger, 10 terabytes. You can increase 6 more systems. You can increase 6 more systems. That is nothing but 6 more nodes. 6 more nodes. So all these nodes are connected to one single network. All these nodes are one single network. That is call it as cluster. That is call it as cluster. What is cluster? Cluster, it is nothing but all nodes are connected to one single network. That is call it as cluster. So in our interview question, the first question is how many nodes of cluster you guys are using? Then you can say 30 node cluster, 70 node cluster. This should be based on your data. You can set your number of nodes. Now tell me, MySQL Rdbms also follows horizontal scaling, and also Hadoop also follows horizontal scaling. Then why Rdbms cannot? So in that Rdbms concepts also we have some limitations are there. For MySQL we can add up to 256 nodes. For SQL we can add 128 nodes. After that we cannot add. Such type of limitations we have. So that's why in MySQL, I mean to say in Rdbms, we cannot process huge volume of data. Okay, so by using Hadoop, there is no limitation for nodes. N number of nodes you can add. So Facebook is currently 30,000 node cluster they are using. Even Google also, it is using the same number of count. That's why Rdbms cannot process huge volume of data. Okay, but Hadoop will process huge volume of data. This Hadoop, who will introduce this Hadoop? Hadoop introduced by duck cutting in the year 2005. It is developed. It was introduced in the year 2005. So here also we can use processing, and here also we can use storage. For processing, we can use MapReduce. Initially we can use MapReduce, and after that we can use, for storage we can use Hdfs. What is Hdfs? Anyone knows Hdfs full form? It's a Hadoop distributed file system. In this MapReduce, we can develop the code by using Java or Java. Can you? I will ask one question. Out of 100 people, suppose out of 1,000 people or out of 10,000 people, how many members knows Java? Just for a guess, only 10 to 25% only maybe knows Java. The remaining people doesn't know Java. Okay, so that's why in 2008 year, Facebook introduced Hive concept. Here also, these are all, we can write SQL queries. Whatever by using Java, we can process structured and semi-structured data. Okay, the same type of data we can process by using Hive also, but the backend should be MapReduce, mapper and a reducer. Two phases are available. So initially, I want to tell you one thing. Hadoop follows which architecture? Master-slave architecture. Okay, master-slave architecture. Suppose, for example, Java follows which type of architecture? Client-server architecture. That is nothing but a request and a response. So here we can distribute the data. How to distribute the data, and how to process the data, and how to store the data. These kind of things we can discuss in Hadoop. Now, in the same year, in the 2008 year, Yahoo was introduced pig concept. So here also, 1 minute, guys. Give me 1 minute. Sorry guys, sorry. Uh, so in 2008, Yahoo was introduced this is the one of the Hadoop ecosystem. All these systems we call it as Hadoop ecosystems. Okay. So by using Pig, we can process structured and unstructured data. Can you please tell me, by using RDBMS, what kind of data we can process? Only structured kind of data we can process. But by using Hadoop, we can process structured data, unstructured data, and semi-structured data. Okay. In suppose, can you please tell me all these components, all this Hive, Pig, all these components, suppose if you want to install by manually, yes or no? By manually you can install all these components, but in 2008 year, in the 2008 year, we have one thing, that is Cloudera is comes into the picture. What is Cloudera? Cloudera is a distribution. Cloudera is a distribution. Okay. Now, what is distribution? Suppose, for example, before, I will give one example. Before Microsoft, what will happen? Before Microsoft, if you want Excel, if you want Word, if you want WordPad, anything you can download or install manually. Am I right? Each and individual component you can install manually, right? But once Microsoft is comes into the picture, we have a Microsoft Windows. What is this Microsoft Windows? All the Excel, Word, WordPad should be comes under Microsoft Word. You no need to install each and every component by manually. All the components are available in one place. Just you want to buy Microsoft Windows, that's it. Then they can provide all the components. That is nothing but MS Excel, MS Word. What is MS? It is nothing but Microsoft. Okay. The same thing here also. You no need to install any above components. That is nothing but all are will be provided by Cloudera. Just you want to pay. You can pay amount for cluster. What is this cluster? Already we have discussed. All number of nodes we can connect it to one single network, that is called it as cluster. So here you can pay amount for cluster. See here, this is your Cloudera. This is your Cloudera. Okay. So in this Cloudera, suppose if you want to, we have a few components are there. That is nothing but Hadoop ecosystems. Suppose if you want to see those Hadoop ecosystems, just we can give Hive. Just we can give Hive. The same way we can give HBase shell. What is HBase? HBase is a NoSQL kind of thing. NoSQL database. HBase is a NoSQL database. MySQL. What is the difference between MySQL and NoSQL? MySQL database, if you want to provide any schema, if you want to create any table, you can create a schema for that. But in NoSQL, you don't want to provide any schema for that. Any n number of columns you can add based on the row key. So most of the people, those who are using huge volume of data, those who are maintaining huge volume of data, they are using only NoSQL kind of databases only. That is nothing but I think you guys are heard these names: MongoDB, Cassandra, and HBase. All these things are coming under NoSQL databases. And also, if you see the Spark also available, Spark hyphen shell. The same way here, Pig. Everything is available on top of distribution, Hadoop distribution. That is kind of Cloudera distribution. In this Cloudera distribution, we can all the Hadoop ecosystems are available. No need to install manually. No need to install manually. See, if you give Hive, it will enter into the Hive prompt. It will enter into the Hive prompt. If you give HBase shell, it will enter into the HBase prompt. Suppose if you give the Spark hyphen shell, it will enter into the Scala prompt. It will enter into the Scala prompt because Spark code is developed by using Scala only initially. Initially, Spark code is developed by using Scala only. But nowadays, we can use Spark with Scala, Spark with Java, and Spark with Python also. See, at the same time, for pig, if you give pig, it will enter into the grunt shell. It will enter into the pig grunt shell. So this is why we no need to install any components. We no need to install any components by using Cloudera. All are available on top. This is single node cluster. This is single node cluster. But in our real time scenario, we cannot use single node cluster. We can use 100% multiple node cluster. That is should be 50 node cluster, 70 node cluster, 100 node cluster. This node cluster we can use in our real time scenario. Okay. Now Hadoop ecosystems. Hadoop ecosystems. So in this Hadoop ecosystems, mainly see guys, in our actually in our batch, suppose I can give Hadoop commands and Linux commands. These are the basic things. First of all, I will start this in our original training, but in Hadoop ecosystems, we have a scoop, pig, hive, HBase, MapReduce, Oozie. Okay. So these are the Hadoop components, Hadoop ecosystems. In Spark, coming to Spark, we have a Spark core, Spark SQL, Spark streaming, Scala, Loom, Kafka, and Cassandra. Okay. So these are the things for comes under Spark. Now today I can discuss about Scoop, Hive, and Spark. Why we are using Scoop, why we are using Hive, and why we are using Spark in our real-time scenario. In our real-time scenario, how we can use these three components. So first of all, Scoop. What is Scoop? Any idea, guys? Any idea about Scoop? Can you please let me know? Any idea? Please ping me in chat. What is Scoop? What is Scoop? Any idea? Can you please give the answer? If yes, either if yes, can you please give the answer? No, please give no. Rashmi. So remaining people. Okay. So Scoop. Why we can use Scoop? We can use Scoop by using Scoop. We can perform two types of operations. One is import and second one is export. One is import and second one is export. So how can we import and how can we export? I will tell you. Suppose for example, okay, this is Amazon India data. This is Amazon US data, and this is Amazon UK data. Okay. So India data is available in one server, US data is available in one server, UK data is available in one server. Suppose all this data, this is one MySQL. Suppose this is in MySQL. This is also MySQL. And this is also MySQL. Okay. Now, you want to, first of all, what you need to do, first of all, you want to import this data, India data, US data, UK data from client place. This is client place. Amazon is client. Now you can place it into, you can import into your place. What is your place? I will tell you. What is your place? This is one, and this is second, and this is third. Okay. Now, so here I want to import. I want to import this India data and US data and as well as UK data. Okay. So by using scoop import, from where to where? From where to where? That is nothing but target RDBMS. This is your RDBMS MySQL to where your HDFS. What is HDFS? Your storage purpose we can use HDFS. What is the full form of HDFS? Hadoop distributed file system. Hadoop distributed file system. Once the data is available on top of this HDFS, see here suppose 100 records are there. Suppose here 100 records are there. All 100 records should be available in your HDFS also, because just we can lift and shift. That is nothing but whatever the data it is available in client location, we can connect to client location target RDBMS and we can place it into our HDFS. So how many records are there? 100 records are there. All 100 records should be now coming to our HDFS. Now the same thing US data and UK data. The same way, suppose after transformations, if you apply, suppose after apply transformations on these three data sets, and now again you can also export. Now you can export the data. You can export the data from. You can export the data from where to where? You can export the data from where to where? HDFS to MySQL. HDFS to MySQL. So import from target RDBMS to HDFS and export to HDFS to target RDBMS. This type of operations we can perform by using Scoop. Okay. Now for Hive and Spark, why we are using Hive and Spark? So Hive we can use for processing plus storage, and also Spark also processing plus storage. So here once the data is available on top of HDFS, how to process this data? We have four options. First one is Pig, second one is Hive, third one is MapReduce, and fourth one is Spark. Okay, so Pig and MapReduce nowadays no one is using. Most of the people are using Hive and Spark. So once processing the data, again you can place the data into tables only. How we can process the data and how we can store the data, we'll see right now. So first of all, what is our main aim? By using scoop import, we can import the data from MySQL or any other database to your HDFS. Now okay, Scoop. So first of all, Scoop. Okay, Suppose how to connect a scoop. So first I can open this MySQL. First I can open. So shall I close all these tabs so that so I want to close all these tabs. I need Spark. I don't want a HBase. Okay, so I can close this one also. This is also I want to close. This is I need. Okay. So first of all, I want to connect my MySQL. First of all, I want to connect MySQL. Okay. So how to connect MySQL? How to connect MySQL, guys? I think you guys know how to connect MySQL. Can you please tell me how to connect MySQL? How to connect MySQL? So it's very simple. MySQL -u root -p Cloudera. So we can give MySQL -u root -p. What is -u? It's a username. What is -p? It's a Cloudera. It's a Cloudera. So enter. So this is I have entered into my MySQL. Okay. So here first of all I want to create my own database. How to create a database? Create a database. Durga 300. This is my database. So I want to use this database. Use Durga 300. Okay. So here show tables. There is no tables. So what I need to do? I want to first of all here we use NoSQL. What, Ravindra? NoSQL? No. Here we can. I didn't understand your question, Ravi. Here we use NoSQL. NoSQL. This is
And
SQL.
actually,
Yeah.
it is a sequel or no sequel, whatever it is.
This is only SQL. This is not a NoSQL. See, NoSQL,
Oh.
NoSQLs are HBase, Cassandra, MongoDB.
Yeah.
Okay. These are all NoSQL database. MySQL, it is not a NoSQL database. Okay. Yeah.
Oh.
Can you please mute? Okay. Thank you. So here, what I need to do, I want to create one table. What is the table? So first of all, create a table employee. Create table employee. So we need to provide some schema. So ID int, name varchar of 50, salary salary int, and the next one department ID int, comma create underscore date is date. This is my table. See now show tables. So now employee is my table. So in this, suppose if I give select star from employee, there is no data. Now I want to insert the data. How can I insert? Insert into employee values 1 comma Surya comma, next one is 1 lakh comma, sorry, department ID 101 comma 2020 hyphen 08 hyphen 09. Okay, now select star from employee. Okay, the same way I want to create few more records. 10 records I need to create. Okay. Now select star from employee. Okay. So 10 records are available. So 10 records are available. Okay. Now here what I need to do, I want to import the data. I want to import the data from MySQL to Hdfs. That is my first step. How can I import? So here I want to use few things. For every scoop import, we need to provide few arguments. What are those arguments? First one is --connect connection URL. --connect connection URL. This connection URL should be MySQL connection URL. Okay. So next one is username. This username, MySQL username. And next one is password. This password is MySQL password. Okay. Next one is table. This table also MySQL table. Next one, number of mappers. This is number of mappers. Number of mappers we need to give. We need to give based on the data. How we can give the number of mappers? We have one formula is there. I will tell you what is the formula. And last one is --target dir. This is Hdfs directory. This is Hdfs directory. Now. So first of all, for every scoop import is common. Scoop import is common. Now I want to write a scoop import for what I need to do, I want to import this table from MySQL to Hdfs directory. How can I do it? So very simple. Scoop import --connect. So first of all, we need to provide a connection URL. This connection URL will provide in our real-time scenario. Who will provide? Your client will provide this connection URL. How can we give? So this is nothing but Jdbc column MySQL column / localhost column 3306. What is this localhost? Either it's a host name or IP address. All this information, connection URL details, real time, client will provide. You no need to bother. So here, can you please tell me what is my database name? What is my database name? Durga 300. See, Durga 300 is my database. Okay. So Durga 300 is my database. Now next one is --table. What is my table? Employee. Next one, number of mappers. How to calculate number of mappers? Number of mappers formula is data size divided by block size. Data size divided by block size. Suppose for example you have, sir, client will provide or database, client will provide Kumar, client will only provide. Okay. So client will only provide, that is nothing but client place. In client place, database admin only will provide. Okay. In client place, people only provide. Okay. Is it clear, Kumar? Okay, cool. Now, suppose for example, your data size is 1 GB. 1 GB, it is nothing but 1024 MB. the default block size of Hadoop 1.x is 64 MB. How many number of mappers? 16 mappers. Okay. The same way, suppose for example, in Hadoop 2.x architecture, 124 MB divided by 128 MB. It is nothing but total 8 mappers. 8 mappers. Okay. So total, this is the way we can give the number of mappers based on your data and block size. Okay. So here, number of mappers I can provide 1. 1 minute. Number of mappers I will provide 1. And the next one is target directory. This target directory should be your Hdfs directory. So I can give scoop import 09082020. Okay, this is my Hdfs directory. For any Hdfs directory, first we can give slash. So now I want to, so here I missed it, hyphen username. What is my username? At the time of connection, at the time of connecting MySQL, I have given username MySQL -u-root, right? See, username is root. Username is root. Hyphen password. Password is Cloudera. Now I want to execute. Where I need to execute this job? You can execute in your local file system. This is your local file system. That is nothing but this is your edge node. Okay. So paste it. Now enter. Scoop import, it will take time, guys. Okay, scoop import, it is taking time. So in our diagram, what I have already given you, how many number of records are available in MySQL? All the number of records should be available in Hdfs after scoop import is completed. Then only our scoop import job is completed successfully. Okay, I got one question. Okay, sir. Meanwhile, can you tell me the real use case of Spark? See, why we are using Spark? First of all, the real use case, it is nothing but, okay. See guys, Spark. So in this Spark, we have to use so many use cases we have. So many use cases is have. How it is? Suppose for example, in our real-time scenario, you have a Hive tables. You have a Hive tables. Okay. So in this Hive tables, your data is available. In this Hive tables, your data is available. Before Spark, how we can process the data in this Hive tables? In this Hive tables, we can apply transformations. We can apply transformations, and again we can place it into Hive tables only. This is before Spark. But after Spark, how we can do? After Spark, how we can do? So my use case is I have a Hive tables. I have total 10 Hive tables. Okay, I want to read this data. I want to read all these 10 tables of data, and I want to join this based on source to target mapping sheet. That is nothing but STM document. That is STM document. That is nothing but source to target mapping sheet. Okay. So on top of this 10 tables, I want to join all these 10 tables, and I can place this data, entire all this 10 tables data into one single table on top of HBase, not into Hive. So I have a Hive tables. All these Hive tables based on the STM document, source to target mapping sheet document. I want to join all these things, and I want to apply transformations. And I can place this into one single table, that is HBase table. This is one scenario. The same way, by using Spark, suppose your data set, your source data is JSON format data, or XML format data, or Avro format data, or PARQ format data. We have a different kinds of semi-structured data are available. These are all under semi-structured data. First we need to read this data, read the data by using data frames, and we can place this data into tables. And now again the same way, joins, transformations, and again you can place this data on top of Hive. This is one use case. Now by using Spark streaming, nowadays everyone is using Spark streaming plus Kafka. How it is? Spark streaming and Kafka. This is live data. It is nothing but, suppose Ola, Uber, Swiggy. Okay, all these are live data only. That is nothing but you want to process this live data. Suppose for example, by using Ola, you can book a cab. First of all, once you can book the cab, you got the details. What is the details? Cab details plus driver details plus OTP. These details you can able to check on your Ola app, on your Ola app. After some time, where the driver is, where is your cab, where is your cab, in how many minutes your cab will reach into your place. These type of information, all this information you can able to check in Ola app only. So what this type of data? This is a streaming data. Streaming data. The same way Swiggy also. Once you have placed an order, first of all, your food is being prepared. This is your first step. After that, one person name you can able to check, you can able to see on your Swiggy app. And after that, in how many minutes he will able to reach your place. All this information, this is a live data. So how we can process this live data? By using Spark streaming and Kafka. The normal Spark code versus Spark streaming code. The configuration wise, it was a little bit difference is there. Why we using Kafka? In this Kafka, we can use some things: producer, consumer, topic, offset. Okay, so something these concepts are available: producer, consumer. So first of all, initially producer, all this data available in producer, and after that the data should be available in topic based on the offset. Offset, it is nothing but, suppose first time it will read 0 to 100 records. After that it will read 101 to 200 records. Likewise, this is the offset value. Then after that, consumer consumes the data. So here we can process, this is a streaming process. Streaming process is 24/7, we can get the data. 24/7 we can get the data. Suppose, for example, before lockdown, Swiggy is available 24/7. Before lockdown, Vola is available 24/7. Before lockdown, Uber is available 24/7. Before lockdown, Zomato is available 24/7. That is nothing but 24/7 streaming is 24/7 streaming data. It is consuming, and again, once this data is coming, again we can place this data into Hive tables or big tables. That is nothing but GCP. What is GCP? GCP, it is nothing but it is a cloud. It's a cloud. So nowadays, all projects are migrated. All projects are migrating from on-premise to cloud. So if you get any mails from Naukri, or suppose if you can check Spark and Scala jobs, Hadoop with Spark and Scala jobs, every day nowadays everyone is asking for any one of the cloud technology you want. I mean to say, you should know about any one of the cloud technologies. Nowadays, how many cloud technologies we have? Cloud technologies. That is nothing but AWS, Microsoft Azure, and next one is GCP. What is GCP? Google Cloud Platform. In this Google Cloud Platform, within fraction of seconds, you can process petabytes of data. This is the advantage. So how to actually this entire code, how we can develop by using Eclipse IDE. For this Scala, we have a separate Eclipse IDE is available. So first you can install that, then you can write your projects. And also here we can write a Maven project. What is Maven project? Suppose, I think you guys are know Java. So how to write a Java? Suppose for example, if you want to write any Java program you have developed, after that you want to, it's a build tool. Yeah. Suppose it's a Java, you have developed one code. So after that you want to add jars. How can we add the jars? Add external jars, build path. Then you can go to add your jars by manually. But in this Maven project, we have one pom.xml file is available. In this pom.xml, we need to add dependencies. We need to add some dependencies. No need to again manually add any jars. So it will automatically in this pom.xml, whatever the dependencies you have add, those jars it will install. It will install automatically. Okay. We need to download the dependency and need to add the info. Exactly, Kumar. Exactly. Yes. So this is the way. This is once the project is completed, we need to use in our real-time scenario Git, Gerrit, and I mean to say Jenkins. Okay, and next I mean to say Airflow, or I mean to say either Airflow or Azkaban or Woozy for scheduling purpose, scheduling your jobs. Okay, so this entire process, this is the entire process currently we are following in our real-time scenario. Okay, not only Hadoop and Spark with Scala, we need to know bit information about these things also, how to schedule and how to we have a Git commands, we have a Gerrit commands, we have a Jenkins. How to so in Jenkins we have a something like a app and configuration ID. App and configuration IDs are available. Based on these IDs, we can deploy our code by using. See, once all these are completed, deploy our code in. We have a three environments are there. Three environments are there. One is dev environment, and second one is UAT environment, and third one is production environment. So in our real-time scenario, what exactly you have done in our production? These are the questions you will get in your real-time scenario. In your real-time scenario, what type of issues you are faced? What type of issues you are faced, and how to resolve those issues? That is the first one. So how to write a code on top of production? How performance tuning? How can you use? So performance tuning is very much important. Performance tuning is important. What type of issues you have faced? What type of issues you have faced? And how to resolve those issues? How to resolve those issues? All these things must and should. What, Ravi? We work in production environment. Yes. Once, see, for everyone, first of all, initially you can develop your code. Initially, sir, difference between UAT and production, could you please brief? Okay, sure. See guys, first of all, initially you can I mean to say develop the code in a dev environment. Okay, so in this dev environment, so whether your code is working fine or not, this is you need to check. Once this is completed, then you can push this code to UAT. Okay, in this UAT, what is UAT? It is a testing purpose. So you have developed the code. For example, suppose for example some interviewer will ask, suppose in interviewer will ask how to add two numbers. You have write a program a equal to 10 int a comma b, a equal to 10, b equal to 20, c equal to a plus b. This is your code. This code is correct or not, who will test? Your interviewer will test. The same way, whatever the code you have written, that code is working fine in your environment. That is nothing but dev environment, it is working fine. But UAT environment, whether it is working or not, what they need to do, they can return some test cases. So all these test cases are passed. All these test cases are passed. They can give sign off. UAT team will give sign off. Once you can get the sign off from UAT people, then after that you can deploy our code into production environment. So in this once this production environment is also working fine, so your data is live. Everyone, all the people, all the people, they can see this data by using UI. What is this UI? User interface. User interface. What is user interface? Everyone knows. Facebook.com. Facebook.com. So you can get one page that is called it as user interface. This is how in our real-time scenario we can do like this. We can do like this. Now going back to our scoop. Kumar, is all your doubts are Kumar, Ravi, everyone, your doubts are clarified? Yes or no? Okay, cool. Thank you. So now, so can you please tell me in our MySQL how many number of records are there? In MySQL, how many number of records are there? Total 10 records are there. See, total 10 rows are there, 10 records are there, right? See, now after import is completed, 10 records are retrieved. How can we see the data? So here we have some Hadoop commands. As I told you before, in our Hadoop course, first of all, I can give this Linux commands and Hadoop commands. How can we check? Suppose, for example, if you want to create any directory on top of, okay, I will tell you one thing. Suppose here in Windows, if you want to create any directory in your in Windows, if you want to create any directory, how can we create a directory? Just right click and you can give new and you can give folder name, that is Durga 300. This is how you can create a directory. The same thing how we can do on top of Linux. Here how can you create? Just we can create mkdir and a directory name is Durga 300. This is how we can create the data. So how we can check the data? ls is the command or ll is the command. Okay, the same way how we can create a directory? Hadoop fs. For any Hadoop command, Hadoop fs is common. For any Hadoop command, Hadoop fs is common. Then hyphen mkdir. See, the command is same, but before that command we can use hyphen symbol. Then I can give Durga 300. So now what is our scoop command? In this scoop command, this is my target directory. Okay, so how can I check this data? How can I check this data for this folder? Hadoop FS. In our I mean to say, on top of Linux, we can use ls, ll, ls-lrt, ls-ltr. We have multiple options are there, but here only we have only ls, and I can give the folder name. So here, so for every success job, we have one, it was created one success file. There is no data in this, but it's showing whether your job is a success or not. Your job is success or not. The second one, in this second one, we have a data in this part m file. And one more thing I want to tell you, in this scoop, only we have mapper face only. Only we have mapper face. There is no reducer face. When we can use reducer face? Whenever you can use aggregate functions. Aggregate functions. What are those aggregate functions? That is nothing but min, max, average, count. Okay, so sum. So whenever you can use this type of aggregate functions, then only the reducer function is there. But in our situation, lift and shift, that is nothing but you just import the data. Whatever the records are available in your scoop in your client place, all the records you are importing into your place. See, if you observe this job, only mapper face is 100%. There is no reducer face. Okay, we'll see later. Okay, I will show you. So here, how can we check the data? So what is the command? What is the command to check the data in on top of Linux? It's a cat command. It's a cat command. Here also we can use the same command. That is Hadoop fs -cat. I want to copy this one. See, all the 10 records are available. See, the default delimiter when you have import the data from any target RDBMS to HDFS, the default delimiter for all the fields terminated is comma only. Fields terminated is comma. So as per our thing, the first thing is completed. We have by using scoop, we can import the data from MySQL to HDFS. This phase one is completed. The next one, I want to use Hive. How can I use Hive? So it's very simple. Already I have opened Hive. So here also I want to create one database. How to create a database? Create database Durga 300. Okay, 1 minute, guys. Now use Durga 300. Now show tables. There is no tables under Durga. So now can you please tell me MySQL? In this MySQL, what kind of data we can store in MySQL? That is nothing but RDBMS. It's a transactional data. It's a transactional data we can store. That is nothing but we can process OLTP, that is online transaction processing. But Hive, it's a analytical data. It's analyze the data, analytical data. That is nothing but it's a OLAP, online analytical data, analytical processing. Okay. So in Hive, we cannot store any transaction data on top of Hive. Whatever the data, if you want to store the transactional data, you can store on top of RDBMS. That data you can import into Hive table. Then you can apply transformations. Again, you can place it into Hive table. Okay. So now how to create a table? So in MySQL, how to create a table? It's just create a table name, and you can provide schema. Table name, you can provide schema. This is the way. But how can we create a table on top of Hive? The table syntax is somehow different. Create table employee, create table employee ID int. So here, can you please tell me one thing? How many columns are there? Here, how many columns are there? Total 5 columns are there. Here, 5 columns are there. So I want to create a table by using 5 columns. ID int, name string, salary int, department ID int, and date of joining date. Okay. The table syntax of Hive. So row format delimited, fields terminated by comma, lines terminated by slash n. See, here fields terminated by comma. What is this fields terminated by comma? Each and every field is terminated by comma only. So each and every line, one line is completed, the second one is new line. Lines terminated by slash n, that is row, that is slash n, it is nothing but new line. Okay. So I want to create this table. Okay. Now on top of Hive, I want to create this table. Okay. Enter. See, now show tables. It's a employee. Show table, it's a employee. Okay. Now I want to load the data. We have total two ways to load the data into Hive table. The first one, load data in path. Our data is available on top of Hdfs directory. So what is our directory name? What is our directory and what is our file name? See this one. This is my data. So this is my data. I want to copy and I can paste it here. Paste, scoop import into table employee. This is one way you can load the data into table. Select star from employee. See, all 10 records are available. And the second way, what is the second way? at the time of table creation only, at the time of table creation only, I have given 1, and here I need to mention location. I mean to mention location. This location, whatever the data I have provided here at the time of loading data, whatever the path I have mentioned, so this path I can give at the time of okay. So now copy, and I want to create the table. I want to create the table. So only one step. Select star from employee 1. Okay, already this data is inserted into one table. So now in this location there is no data. In this location there is no data. What I need to do, I want to copy in this location. I want to copy the data. 1 minute. Hadoop fs-hive/user/warehouse/Durga 300.db/employee. So what is this user hive warehouse? User hive warehouse is the default location. Whenever if you want to create any table, all these tables are created under /user/hive/warehouse only. Okay, 1 minute, guys. Why it is not there? 1 minute. I want to check the location. Okay. So how can we check the location? Show tables. I have total 2 tables, employee and employee 1. I want to check the DESC employee. It is giving only schema. DESC employee, it is giving schema, but DESC formatted employee, in this it will give the location also. This is the location. So this is the location. Okay, copy. I want to copy this location, and I can Hadoop fs-ls. Hadoop fs-cat. Copy, paste. So I want to copy this one. I want to copy Hadoop fs-ls. What is my scoop target directory? What is my scoop target directory? It's a, this one is my scoop target directory. Okay. In this, paste. Only success file is available. I think so. There is no success file also. Okay. So see, now it's a directory. So see, Hadoop fs-ls. I want to give this one. Copy. paste. See what it is showing? It is showing 0 records. It is showing 0 records. What I need to do? Hadoop fs hyphen rmdir. I want to remove this one. Paste. Okay. Now what I need to do? Hadoop fs hyphen cp. Hadoop fs hyphen cp. I want to copy this file to. I want to copy this file to paste, and I can paste it in. I want copy into this location. Copy. Enter. Now what is the CP? CP, it is nothing but we can copy a file from one location to another location, right? The same thing here also we can perform. The file we can copy from one location to another location. One location to another location. Now can you see here, file is available. Now file is available. Okay. Now already you have created a table by using this path only. Now I want to check the data. Select the star from employee 1. See, previously there is no data because there is no file. Now I have copied a file. See, previously no data. Now I have copied a file. Now we can get the data, right? Now we can get the data. So here one step is we don't want to go for 2 steps. First one is create table and second one is load data. So here we cannot use load statement. Just we can give the location. That is the advantage in Hive. That is the advantage in Hive. Based on the location, it can load the data into table. Now on top of this, if you want to perform any select count of star from employee 1, or you can perform select id comma sum of salary from employee 1 group by id. Okay, group by id. So this type of operations, join operations, group by operations, order by operations, filter operations, all these things we can perform on top of Hive. Okay, the same thing we can perform on top of Hive also. Guys, I want one request. Can you please wait for 5 to 10 minutes? 5 to 10 minutes. I will be back in 10 minutes. If people are see, I have very some urgent work. So if you guys are waiting, so I will be back in 5 to 10 minutes, or else we will wind up this session. How long is the session? Just next one is Spark. How to read this data into Spark. It's just 10 to 15 minutes. That's it. How to read the data from Spark with Spark. How we can read the Hive tables and other these things. Okay. Once it is completed, Yeah, sure. See, if you go to Durgasoft, www.durgasoft.com, there you can find out Hadoop and Spark with the Scala course content. Okay. So there you can able to identify. See guys, whenever you can apply any aggregate functions, then only the reducer phase will be comes into the picture. Then only the reducer phase will comes into the picture. Otherwise there is no reducer phase. See here, reducer also completed 100%. If you observe, see here, 100% it is completed. Okay. The similar operations we can perform by using in Spark, by using val Spark df equal to SQL context dot SQL. Here you can give select whatever the statement you have run here. The same statement you can give the Spark side. You can give the Spark side and you can run. See, what is the difference between Hive and Spark? It is nothing but where we use Java here. Guys, Java in our Hadoop we can use in MapReduce program only. Now it is MapReduce program. Nowadays no one is using. Everyone is using Spark only. We can do by using Spark development. We can use by Spark with Scala, Spark with Python, and Spark with one more thing is Spark with Java. Okay, any one of the technology we can use. So in our training, I can provide Spark with Scala. Okay, guys. So this is the way we can run the program. So course content is available in Durgasoft, and the second one is, so this batch will start from tomorrow. 7 to 8 p.m. 7 p.m. to 8 p.m. is the class. Okay. So if you have any doubts, please message me Hadoop developer 9999@gmail.com. This is my email ID. If you have any doubts, please ping me just your name. So just I have attended today's Spark with the Scala this workshop. If you have any doubts, because we'll be in office work. Ravi, can you speak? So I will mute. I can unmute yourself. Now you can speak out. Ravi, what happens? So 7 to 8, you 7 to 8. You guys having any? I mean to say off.
Yeah, actually, I'm from production support team where we used to support many of the things. So it will take around 8 o'clock. So later on from 8, can we have the class?
Okay. Remaining people: Akhil, Kumar, Prakash, Rashmi. So you guys are also interested to join in this Hadoop training. First of all, can you please give the answer yes or no? Just no problem. Okay, no problem. If yes, then yes. No, no. Rashmi, yes. And Prakash Mutaneni, yes. Okay, what about Kumar and what about Akhil? Okay, guys, it's up to you. So class will start if you guys are okay. 8 p.m. to 9 p.m. What is to be made for this mail? Huh?
Yeah.
What, Ravi?
Mean for this, what we need some details so we can mail to this.
Yeah. That's what. you have any other questions, please mail me. So
Yeah.
if everyone is okay for 8 to 9 batch, then I can give the 8 to 9 o'clock class. Okay, guys. First of all, you guys should be okay. You guys will decide if 8 to 9 is okay. Then I will start the session from 8 to 9 only. Are you okay? Okay, we'll see. Okay, guys. We'll meet tomorrow. At 8 o'clock only. At 8 o'clock. Okay. Yeah. Thank you. Thank you, guys. If any questions, please ping me in. Please send an email so that I will check and I will give you a reply. Thank you.